Solving exponential equations. Recall that we've talked about the change of base formula. If I have the log base a of b, that's equal to the log of b over the log of 10 using base 10. It allows us to do in our calculator. For those of you who have older calculators that don't allow you to use the math log base button, if we have the math log base button, of course, that's a lot easier to use, but it's good to know the change of base because they do like to use it on standardized testing. Looking at question number 1, we have the log base 6 of 11. So if we use a change of base formula, this would be the log of 11 divided by the log of 6. So if I go to my calculator and plug that in, log 11, make sure you close that parentheses there, otherwise you'll get a different answer, divided by the log of 6, again, close parentheses, enter, and you get 1.3383. We're going to round using 4 decimals. If you have a newer calculator, you have that math, and if you scroll down, you'll get that log base, and you can actually plug it in, which is a lot easier, of course. So it gives you the same answer, just 2 different ways. Some people don't have the button in the calculator to use, which is why we have to show both ways. So again, we're going to round using 4 decimal places for this. So we said that was 1.3383. Looking at the next one, our next 2, why don't you go ahead and pause, and then on pause when you're done, we'll go ahead and check our work. So for this one, the change of base formula is log of 32 divided by the log of 4. And so that gives us 2.5. And this one over here, the log of 24 over 11 divided by the log of 3, and that gives us 0.7101. Okay, so that's it for the change of base formula. Let's go ahead and look at exponential equations. So for exponential equations, if b to the x is equal to b to the y, then x has to be equal to y. So for this first problem, you can see that you have a base 5 equals a base 5. So that means you're going to solve by setting the exponents equal. So 2x plus 3 equals 4x minus 5. And then you just have to solve. So subtract the 2x. We get 3 is equal to 2x minus 5. Add the 5. 8 is equal to 2x divided by 2. And x is equal to 4. So now when you're solving exponential equations, recall that the domain for an exponential equation is all real numbers. Unlike when we were solving logarithmic equations, we can't take the log of 0 or a negative number, and so we had to make sure the answer was within the domain. So that's nice for these problems that we don't have to worry about that. However, it's still a good idea to check your work, to plug it in, especially if it's an assessment, because that way at least you know you're getting the correct answer. So always check your work in the original problem. So if you plug the 4 back into this original problem, you would see that both sides are equal to each other. So looking at question number 5, again, we're solving by equating the exponents. So for this, notice that the bases are not the same, but the question is, can we make the bases so that they are the same? The answer is yes. So when you're making the bases the same, always look at the smaller one to kind of guide you, and be careful. So just as an example, like if I had 3 to the power of x equals 9, and I want to solve this. Well, we know that the answer to this is x is equal to 2 because we know 3 squared is 9. However, when you're doing problems where you don't know, it makes it a little bit more difficult. And I often see students will try to change the lower number to match the higher number. And I will see a lot of times students try to write this 3 to the 2x equals 9. And this changes the problem because 3 squared is not the same as 3. They are not equal to each other. So you have now changed the equation. And if I solve this problem right here, okay, so 3 squared they say is 9 to the x equals 9, then they say x is equal to 1. Well, we know that is not the case. So you always want to change the higher number into the lower base if you're going to do that. So 3 to the x is equal to 3 squared because we know 3 squared equals 9. So because that's true, that's why I can do this. Now that I have the same base, I set the exponents equal, and x is equal to 2, and that checks out. So again, just always be careful with that idea. So if we look at question number 5, Looking at the lower base, we can see it is a base of 3. So I have to think 3 to what power gives me 81. So that would be, of course, 3 to the 4th power. And of course, I don't like to work with a 3 in the denominator, so I want to move that up to the numerator. And remember, to move it up to the numerator, you just make the exponent negative. So 3 to the negative 1 power is the same thing as 1/3. And over here, 81 is the same thing as 3 to the 4th. So because those values are equal, we have not changed our equation, like the example I showed. So for this, now we have the same base. Both bases are 3, and we can go ahead and equate the exponents. So if I set the exponents equal, notice that we have the 3 minus x times the 4 here, and the negative 1 times all of this. So I'm going to put that in parentheses. So 4 times 3 minus x has to be equal to negative 1 times 5x minus 6, because remember the property, product, or not product property, but the power of power property means you multiply the exponents. So 4 times 3 is 12, and then minus 4x is equal to negative 5x plus 6, and then you want to solve for x. So I'm going to add the 5x, and I get 12 plus x equals 6. And then here, subtract the 12, x equals negative 6. And then once again, make sure you plug that back in to check your work, and you would see that both sides are equal to each other. So that's when we can make the bases the same. So what happens if we can't make the bases the same? We're going to solve by rewriting both sides as a logarithmic equation. So again, this is if cannot rewrite the equation with the same base. And exponent is on one side only. And when we do this, you're going to isolate the exponential expression first. So make sure you always isolate the exponential expression first. Remember, the exponential expression is the base to the exponent. So like this whole entire thing would be the exponential expression, b to the e power. So looking at question 6. So 625, I cannot use base 10 to get 625 because I know 10 to the first power is 10, 10 squared is 100, and 10 to the third is 1,000. 625 is in between it. So that's how I know I cannot equate the exponents and set them equal, because I can't get the same bases. So because I can't get the same base, I want to rewrite in log form. So for this, make sure you isolate the exponential expression part first, which it's already done. So the exponential expression part is right here. It's the base with the exponent, 10 to the 4x plus 1. So I'm going to isolate that, done. Now I can go ahead and rewrite it in log form. So remember, the base stays the base, so this is the log base 10 of 625 is equal to the exponent, 4x plus 1. So that's why we like to write it in log form, because it allows us to take this exponent and bring it down so it's no longer an exponent. And then, of course, we can go ahead and actually solve. So for this, if you have this in your calculator, you can go ahead and just don't plug it in now, but wait until you have x solved by itself first so we can have a more exact answer. So the next step would be to subtract the 1 and divide by 4. So this would be the x is equal to the log base 10 of 625, all of that minus the 1, and then divide by the 4. Because remember, when you do this, you do PEMDAS backwards. And so we got rid of added, subtracted, then multiplied or divided. So you want to do this minus the 1, then divide that by 4. So I would put parentheses around this portion right here if you're plugging this into your calculator. So wait till the very end to use your decimal expression because, again, in upper level math, we want to have as most exact answers as possible. So the log of 10, we can just use this log button right here. If you want to use the math log base, you can, but it's the same thing because it's base 10 and this is base 10 right here. So in my calculator, I'm going to use parentheses, the log base 10 of 625, close parentheses there. Don't forget to do that, otherwise you will get a different answer. And then close parentheses twice because I'm closing that first set of parentheses and this one. So this close to this one, and then, oh, sorry, not twice because we already closed that one. Just kidding. Once, and then divide by 4 because I was just counting 1, 2, 1, 2. And that gives us 0.44 and 897, so 4490 when we round. Make sure you practice and see that you can plug that in because often students get these problems incorrect only because they're not plugging it correctly into the calculator. Could you do it all separately? Sure. And again, if you want to use that math log base button, that's fine. So if you actually want to plug in math log base of 625 and then enter, and then subtract the 1, enter, and then divide it by 4, enter, that's fine because your calculator keeps that answer each time. So if you don't want to plug it in all together, that's okay to do it like that. Looking at the next one, same thing. I cannot make the bases the same because I know 2 to the first is 2, and 2 squared is 4, and 2 to the third is 8, and 5 is in between 4 and 8, so therefore we're going to use logs to solve. So rewrite this in logarithmic form. Log base 2 of 5 is equal to x. And so now I can use my math log base in my calculator that we've learned. So x is equal to 2.3219. Again, if you don't have that math log base, then you have to use the change base. So you'd have to do the log of 5 divided by the log of 2, which gives you 2.3219, same thing. Same thing with the first problem, you would have to use a change base formula. So if you need to use the change base formula, that's okay if you don't have that math log base. Looking at question number 8. So again, before we do anything, the first thing you want to do is isolate that exponential portion. So right here, notice this is the exponential portion and we have that minus 5. So we need to get rid of that minus 5 before we can do anything. So I'm going to add the 5 to the other side. So now I have 7 to the 9x power is equal to 15. Then I would check, can I make these bases the same? No, I cannot. Therefore, then I can go ahead and rewrite this using log form. So this is the log. What's the base? Remember, the base stays the base. So log base 7 of 15 equals the exponent 9x. And again, you can use the change base formula here, or you can use our log base number. And then to solve for x, we have to divide by 9. So if I was plugging this into my calculator, again, we want to go to math. We can use that log base. So math log base, what was it? 7 of 15, enter, divided by 9, and that gives us 0.1546. Or if you need to use a change of base formula, you can. The log of 15, parentheses, divided by the log of 7, close parentheses, and hit enter, and then divide that answer by 9. So be careful with parentheses if you do it that way. So this gives us 0.1546. Looking at the next one, again, isolate the exponential portion, which it's already done. Go ahead and pause the video, see if you can do this on your own. Then when you're done, you can unpause and we'll check our work. So for this problem, we cannot make 9 into a base of 5. Therefore, we would want to write this in log form. So log base 5 of 9 equals 2x plus 7. Then we would subtract the 7. So log base 5 of 9 minus the 7 equals 2x, and then we divide by that 2. So x is equal to log of base 5 of 9 minus 7 divided by 2 is how you plug it into your calculator. Unless you're using the change base, then you would have to use that. When you plug this in, you should have gotten negative 2.8174. If you didn't, make sure you check your parentheses. And that is it for solving exponential equations. So as you can see, it's a little bit easier than solving logarithmic equations because we're more used to solving exponentials. We've worked with these equations before. You just have to know a little bit about, um, you know, exponents as you're solving. And again, keep in mind the domain's all real numbers. And of course, you could always check your work by plugging your answer into the equation. But if you round it, it's not going to be exact. It might be slightly different. So like, let's look at number 9. If I wanted to check my work, I would plug it back in. So 5 to the 2 times negative 2.8174, and then plus 7. And if I hit enter, notice it's not exactly 9, but that's because I used it as the round answer, but close enough. So it's just an easy way to check your work.